I'm Dave McKay. I'm the technical lead for the Cybersecurity Research Lab at the Ted Rogers School of Business at Toronto Metropolitan University. And that's a big mouthful to go along with the title. So what I really want to discuss are trust registries. So to get us there, I've made this little meme here. On the internet, no one knows you're a cat. So we have a problem with the internet where there's no identity layer. So everything is anonymous, and we have to sort of try to add trust on top of that of who you're actually doing interactions with. So in the last talk, and probably some other talks, people have talked about self-sovereign identity, SSI, using tools like Hyperledger Aries, and that uses verifiable credentials. So most of the digital identity systems out there now are using verifiable credentials. Well, how can we trust the verifiable credentials? Well, they use cryptographic signatures where one party signs a claim about another party. Okay, great, so we have cryptography there. But where do we find these, the public keys for these? And so that's, a lot of people will store those on blockchains or have other ways of mechanisms of discovery of the public keys. And in the blockchains, actually, you can see who wrote that transaction there based on their account. But how can we trust the data that's being put in there? So this data has come from off blockchain. So let's say it's a government has issued a permission to me to drive a car, so a driver's license. So how do I know that that was the government that issued that, or if that was the part of the government that was allowed to issue that to me? And so this is where a trust registry comes in. How can you trust these things? So at some point, the machine trust doesn't carry it. You have to have humans involved, because humans don't know what the proper, or machines don't know what the proper government is or who a person is. You have to have people involved with this. So what does the human trust look like in this? What are the requirements for a trust registry? What are people working on now? And I'm proposing a little solution at the end here. So for self-sovereign identity, if you've ever run into it, you'll see that they have this concept of the trust triangle, where they have the issuer, the holder, and the verifier. And there's cryptography going throughout there. There are secure protocols in sending these things across. You have the verified credentials, you have proof presentations. So there's really, really strong protocols and cryptography in here. And that's fine, but the actual data itself, you need humans to be involved with there. So what does human trust look like in identity? So a lot of times there's vouching for claims. So if I say Dr. Mashutan here is a doctor and works at Toronto Metropolitan University, I vouch for them, and you probably will trust that that's true. We could make her come up and show us her diplomas and certificates and employee contracts. That would be identity proofing. Collective decision making, so if all of the colleagues of hers sort of agree, and then we can review and audit documentation. So those are the sort of things we can do with a human trust. And when we talk about trust, there is an interesting concept of trying to put sort of values to that trust. So the levels of assurance of the trust. So several groups have tried to capture this. NIST in the United States has 3 levels of trust, from self-asserted, I am the king of Canada, to actual identity proofing and multiple documentation, which proves that I'm not the king of Canada. The Canadian government has a very similar thing with 4 levels. One I'm interested in is the Internet Engineering Task Force, and they're looking at vectors of trust. So they're looking at several different factors and where you are in a spectrum there, as opposed to just like a single number. Okay, so what is a trust registry? So a trust registry takes care of who can issue what and who can see what. And what do I mean by that? So in the who can issue what, so who are the authorized issuers of a type of credential? So I talked about the provincial driver's license. So obviously the provinces of Canada would be in charge of issuing those credentials, not Toronto Metropolitan University or Tim Hortons Coffee or Dave's issuer service. So it allows people to trust that that type of credential has come from a trusted source. The next part is who is authorized to look at the attributes of one of these credentials. So a driver's license will have more than just the driver's license number. It has your name, your address, your date of birth, your weight, your eye color. That's a lot of information that's on there. And let's say an example of where you just need age verification. You go into a bar and you want to prove that here in Ontario you have to be 19 plus to drink. So you want to prove that, but you don't want to show all this other information. There are dangerous people out there, and a lot of people don't want to give that type of information when it's not required. So it's that sort of principle of least access that's required. Now, how does this information get in there of who can issue what, who can see what? That's where you need a governance group, okay? And so the trust registry is going to be two parts. It's going to be the machine trust of all of those aspects around the credentials themselves, and the governance, which is the human part. Okay, so what do I see as the requirements for this? So you're going to need transparency. You want anyone to be able to follow the process that's happened on this. So who's made these decisions? What criteria did they use? What were the decisions that were actually made and recorded? So you need to be able to see that. It has to be equitable. This isn't like a special club that people have, or a hidden government department, or a conglomerate of corporations that keep this all secret. This needs to be open and accessible to anyone to participate. It needs to be immutable. So if you have decisions that are made, you don't want people to be able to change these. These identities are going to be used in pretty much every online transaction, whether it's a corporation, an individual, an IoT device. You don't want people to be able to change this, because that changes a lot of things. There could be a lot of fraud involved with that. It needs to be distributed. People need to be able to have easy and free access to this information. It needs to be machine readable. You need to have software that can actually go and get this and determine, is this an actual authorized organization to issue this type of credential? If someone is asking to see this information, you can selectively disclose the information to them based on what the trust registry says. And it needs to be interoperable. There's going to be lots of different types of trust registries. Okay, there's some similar systems in use today. So because the internet is a bit of a decentralized system, and we've tried to impose certain things on there. So domain names, like so daveserver.torontomu.ca. So that's my domain name, but the sort of authority for that is split up into different places. So ICANN runs the top level, and they'll say, oh, okay, this is .ca, so that goes to the name servers for Canada, and then, the registrars for .ca domains, and then that passes through to whatever the name server is that takes care of Dave's servers, and then it returns an IP address. So it's kind of a hierarchical system. Certificate authority is very similar if you've ever gone to a website with HTTPS. So that's SSL cert that is created. And so across the internet, they've decided here are some root certificate authorities. And so you go to apply to them to get a certificate, and you'll see the chain all the way down from the root CA maybe to a vendor that's providing these services to your actual SSL cert. So that actually has a chain, which is interesting. I'm a little questionable about this system now. There's like an open source thing called Let's Encrypt that allows anybody to set up their own SSL certs, but it's not actually, no one actually validates you. There's no identity proofing going on with that. So, and no one really goes and looks at the chain of authority on this. So, how did we do this before the internet? Okay, so there's interesting things we can learn from how people sort of vouched for each other within their groups and across distance. So there's the basic vouching, like we're all in the room here and I vouched for Dr. Mashetan. Now if, let's say I was traveling to some university in Europe, Dr. Mashetan could write a letter of introduction from me that I could then present to people, and they say, oh, okay, we've heard of Dr. Mashetan, and so they are vouching for you based on this letter, okay, we will accept you. They had other systems, peerage, which would have been like a centralized system where they've set up the history of who was married to who and what their children were, sort of a genealogy. Heraldry, I could have my heraldry printed on my, I don't know, suit of armor or something. Seals, you've all seen this where they have the wax seal that shows it is from someone, it hasn't been tampered with. More recently, we have notaries. A notary will work as a witness that they've witnessed a certain document. Maybe you signed something. Another interesting concept is apostille. This is where you can take a government document and have it certified to show to another government. So that's an interesting concept. Okay, who is taking this sort of thing on right now? So the Trust Over IP Foundation, they have an approach called the Trust Registry Protocol Specifications. They're working through this. As far as I can tell, this is very blockchain based. The Decentralized Identity Foundation, they have a trust establishment, which is a series of documents. It's more like what the certificate authorities are doing. Cardia doesn't believe in using blockchain, so they have their governance generate these lists, and you just get copies of these lists you can use, whether online or offline. GLIFE is the Global Legal Entity Identity Foundation. That's another mouthful. And they have their organization's nonprofit organization out of Switzerland, and they're kind of it's more like DNS or certificate authorities. They're the top level, and you see the chain of who's approved the identity going all the way through. So based on those requirements I listed out, what I did was I mapped the different approaches that people were doing, and I found that they don't always fit. So nobody has like a perfect fit for the criteria I laid out. Mind you, it's subjective, it's my criteria. But I had picked the criteria because a lot of this, it's decentralized, a lot of it sounds like blockchain. So these properties like transparency, immutability, distributed, these are all sort of blockchain type properties. So what I did was I took a look at this in a Venn diagram. I said, okay, well we have, some people are way up in the world of claims. So GLIFE has these cryptographic claims that take you all the way through. They have a chain. Trust over IP is very blockchain based. Cardia is all governance, and they create these lists that people use. And DIF is somewhere between GLIFE and Cardia. So what would a system look like that sits in the middle of this? My little question mark there. Okay, so what I did was I decided that because all these properties, the requirements that I laid out, seemed like a blockchain, I decided, okay, I'm going to do this trust registry in a blockchain. And what I'm going to do is I'm going to have smart contracts where we map the identity of whoever is issuing or the identity of whoever is trying to verify against a record that says, can they issue this? Or what attributes are they allowed to verify? Okay, so it's a pretty straightforward set of smart contracts to do this. So the sort of things I have is, are they authorized to issue? What fields can they request for selective disclosure? And then the signatures of who's actually authorized this. So with the governance organization, when they make a decision, then all of the people who were part of that decision, their signatures, it's a multi-sig, are included in the transaction record that goes ahead and creates that entry in the trust registry. So this goes back to that transparency. Who approved this organization being that organization? So the trust record is output of the decision from the governance organization. So this is where the human trust meets the machine trust. Okay, so we have the humans, they make their decision, they vote by signing the transaction is sent to the blockchain. Now there can be multiple trust registries. I don't think we'll have a single trust registry for the world, because how are you going to get an organization that can sort of vouch for different organizations and people? It makes more sense to have these things split up either by region or by industry sector or a combination of the two. And then you can also have your trust registries give you a list of approved trust registries. So if you're in a supply chain, you might be dealing with 50 different trust registries from the different industries, insurance and logistics and mining and packaging and shipping, like all of these different trust registries. So your registry would be able to tell you, yes, you can trust these trust registries. It's an interesting concept. Okay, so let's take what I'm proposing and go back to these requirements that I outlined. So I said there needs to be transparency. Okay, so decisions are visible in the registry. You can see what exactly an organization, if they have authorization to issue this credential or not, and you can see who granted that by the signatures and then the identity of those people who signed it. So if a company is fraudulently set up, let's say somebody sets up the province of Saskatoon and they start issuing driver's licenses. That's fraudulent. So who allowed that to go into the registry? You can see those individuals, and then the governance organization can have whatever kind of way of dealing with people like that. It may actually go to the police because this is part of fraud. Equitable. So a lot of this comes back to the decentralized governance and how that's set up. But because people have access to a blockchain, if you use let's say a private or a public blockchain that you provide access to people to, then you have that equitable piece. It's immutable. It's a blockchain system. You can see the decisions that are written there. And so if anyone wants to make a change to one of those decisions, then you'll see through the ledger what the prior one was, what the new one was, that it's gone through the proper process, and you can see the people who were involved in the initial one and the people who were involved in the new version. And then any questions could go back to them on why they did that. It's distributed. Anyone should be able to run a node that has access to the registry. So if it's on a public or private blockchain, you can run a node, and now you have a copy of those smart contracts and all the transactions that went into it. So you'll have all of these decisions at your fingertips that you can use for your software. Needs to be machine readable. This is great. We have RPC calls that your machine can make to the blockchain to retrieve the data from the smart contracts. Blockchain reads are free. If you're not changing the state information, then that's completely free to do. And interoperability. And actually, I'm done.